Alright, so in this problem we are looking at gun control, and it says that historically the percentage of US residents who support gun control, stricter gun control laws, has been 52%. A recent Gallup poll of 1,011 people showed 495 in favor of stricter gun control. So historically, P is equal to 0.52, and in our poll we had a total of 1,011 people, and 495 support stricter gun control. Okay, and it says assume the poll was given to a random sample of people. Test the claim that the proportion of those favoring stricter gun control has changed. Okay, so has the proportion changed is the question. And from there, we're going to use a significance level of 0.05. That's what it says. And it says choose one of the following conclusions. All right, and so we've got to work through that. So in our case, we're going to define our null and our alternative hypotheses. Okay, so our null hypothesis is that the proportion of people who want stricter gun control has not changed. Okay, that it's still 0.52, and our alternative is that it has changed. Okay, so for this I'm using a not equal to sign, and this is the proportion has changed. So our null is that it's still the same at 0.52, and the alternative is that it has changed. It's no longer 0.52. So this is a two-sided test, or two-tailed test. Okay, now we can check the conditions, but yes, we have a random sample. Our sample is large enough, and our population is more than 10 times our sample size. Okay, so I can list those off, but random, yes. Okay, large sample. Okay, we can check n times p, and we get larger than 10, and large population. Okay, we're just assuming this is coming from all adults, so we're good there. Okay, so we have to create our test statistic. So our test statistic is going to be what we observed minus what our null hypothesis states divided by our standard error. So what did we observe? We observed p hat is equal to 495 out of 1,011 people want stricter gun control laws. So 495 divided by 1,011 is 0.4896. Okay, so that 4896. I'm going to go ahead and just round that off to 0.49. That's fine. Okay. My null hypothesis states we're expecting 0.52, and my standard error comes from the null hypothesis, so this is going to be the square root of 0.52 times 1 minus 0.52, which gives me 0.48, divided by n, which is 1,011 people. So my standard error, 0.52 times 0.48 divided by 1,011, take the square root of that, and here I have 0.0157. I'm going to keep the decimals there. So my test statistic is what I observed, 0.49, minus my null, 0.52, divided by my standard error, 0.0157. This gives me, on top I have negative 0.03 divided by 0.0157, and I get a z-score of 1.91, negative 1.91. Okay, and so my final answer, my test statistic is negative 1.91. So I draw a line over there, and because it's two-tailed, I'm going to look at both tail areas. So when I look up negative 1.91 in my z table, the area to the left there is 0.0281. And that means the area over here is 0.0281. Okay, and so the area, total area, my p-value ends up being 0.0562. Okay, this is larger than my alpha, which is 0.05, just barely larger than my alpha, but it's larger than my alpha, so I do not reject the null. And so that means the conclusion that I've come to is that the percentage is not significantly different from 52%. The percentage is not significantly different from 52%.